So this was the analysis of how to find the direction of torque. But torque is a vector quantity, which means it definitely has a magnitude. So now we come to the formula of torque. How is torque found? So consider a rectangular rod which is hinged on the left side and the force is applied. So the object is going to rotate. So before I show you the formula of torque, it is very important. It is extremely important for you to remember that torque is always measured with respect to a particular point. So for example, when we dealt with forces, so let's say 10 Newton force. So that 10 Newton force magnitude never changes, but the magnitude of torque will change depending on the reference point. Let me explain what do I mean by that. So first of all, consider a point P about which we are supposed to find the torque. So the object was hinged on the left hand. So we are considering that particular point as the point about which the torque is to be found. So what is the formula of torque? It is given by Rf sine theta. But remember, torque is about a particular point. In this case, we are considering the leftmost end as that particular point. So torque is Rf sine theta. So let's understand all the variables involved. So this is a Greek letter tau. It is the torque about the point P in this situation. F is the applied force and R is the most important parameter here. R stands for the distance between the point P. P is the point about which the torque is to be found. So the distance between the point P and the point of application of force. So in this diagram, you can see this is the R. R is basically just distance. And finally, we have theta. What does theta stand for? Theta is the angle between R and F. So the direction of force is over here and the direction of R is here. So if I draw a dotted line parallel to R passing through the point of application of force, so this particular angle will be that angle which we require for this formula. So theta is the angle between R and F. But if you watch carefully, the angle between R and F can also be written as 180 minus theta. So this is the angle theta, and this particular angle on the left hand side, this will be 180 minus theta. Over here, this will be 180 minus theta. So there are of course two angles, but which angle do we consider while using the formula? The answer is you can use any one, either theta or 180 minus theta. It is going to give you the same value. Let me explain how. So whenever in the questions we have to find only the magnitude of torque, so we will use the formula Rf sine theta, but with the mod sign. So Rf sine theta is under the mod symbol. Now, instead of theta, if we use 180 minus theta, even then the magnitude will be the same because sine 180 minus theta and sine theta, they are actually equal. Okay, this is from the basics of trigonometry in maths. So this was the magnitude of torque and the direction of torque is either clockwise or anti-clockwise. So in this case, this object is rotating in the anti-clockwise fashion. So we can say direction of torque is anti-clockwise. And finally, what do you think is the unit of torque? So how to find the unit of any physical quantity? We go back to the formula. So torque is R F sine theta. R is distance, whose unit is meter. F is force, whose unit is Newton. And theta, although theta does have a unit, it either is in degrees or radians, but sine theta, sine of any angle is just a number. It does not have any unit. So the overall unit of torque will be Newton meters. Now, back to the most important point. Remember, torque is always measured with respect to a particular point. So in this situation, we had found the torque about the point P. So let us try to change the point. So instead of the point P, let's consider the rightmost end. The rightmost end is point Q about which the force is passing. So in this case, we are going to find the torque of the same force but about this point Q. So we go back to the formula torque is Rf sine theta. In this case, we are finding the torque about the point Q. F is the applied force and then R will be the distance between the point Q and the point of application of force. Please be very careful in understanding this logic. In the previous case, where we were finding the torque about point P, the distance was between the point P and the point of application of force. In this case, we are finding the torque about the point Q. Now, the force is actually passing through the same point Q, which means we can say distance between that force and the point is actually zero. So R is equal to zero. Hence, in this situation, the torque about the point Q will be considered as zero. And that is why from this point onwards, just remember a basic logic. Torque of a force about a particular point will be zero if that force is passing through that point. And this is the concept which we are going to use in a lot of questions. So remember the shortcut in questions. We will always find torque about a point through which maximum number of forces are passing. And why are we doing that? Remember the logic. If the force is acting through the point about which torque is to be found, then the torque is considered as zero. So we always find torque about a point through which maximum number of forces are passing. If this is the condition, if the question has not specified the point about which torques are to be found. So if the question has not given any of this information, then we can find torque about any point. So preferably we choose that point about which maximum number of forces are passing. So let me explain this with the help of a diagram. So have a look. It's the same rectangular object, but check how many forces are acting. Four forces are acting. So there are three forces which are acting at the rightmost point Q, and on the left hand side F4 there is one force acting. So there will be two approaches. Either we find the torque about the point Q, or we find the torque about the point P. Let's consider case 1. We are finding the torques about the point Q. Now, all these three forces, F1, F2, F3, are passing through the point Q. That means we can consider the torques of all these three forces to be zero, like we discussed earlier. On the other hand, F4, F4 is not passing through the point Q. How to check that? What you can do is you can draw a dotted line along the line of F4. So if this is the line, let's create a dotted line. So this line will go like this, and this dotted line, since it is not passing through the point Q, and that is why the torque of F4 about the point Q will not be zero. So this is the case 1. Now we can find the torques of all these forces about the point P as well. So in this case, F1, F2, F3 are not passing through the point P. That means the torques of all these three forces will not be zero. On the other hand, F4 is passing through the point P. So torque of F4 about the point P will be zero. Now, in the exam questions, you can use either of these approaches, but which one is better? Watch. It is very easy to do the calculations if you are finding the torques about a point through which maximum number of forces are passing, because then torque of all those forces will become zero. So in this situation, it is easier to find the torques about the point Q. So depending on question, we can select any point, but do remember a particular condition. The question should not have specified that the torque is to be found about a particular point. If the question has not specified anything, then we as students can find torque about any point. Now, let us understand this concept in a little more detail using an animation. So let's say we have a rectangular object which is hinged at the rightmost end, and we have to find the torque about the same point Q. Now, please be very careful. These are two different points. One is the hinge point, and then the other point is the point about which the torque is to be found. So these 2 points can either be different or they can be same also. So like in this situation, we have hinged the rod at the rightmost point. That's number one. And the second point is the point about which we have to find the torque. So both of these points are the same in this situation. So like we discussed earlier, torque of this force about the point Q will be zero since the force is passing through that particular point. And now let us try to understand this with the help of an animation. Now, in the real world, we use doors on a daily basis. So, when you have to open a door, you either pull or push. So, we are applying a force, but where is that force being applied is extremely crucial while opening a door. There are some points on the door on which, if you apply the forces, the door will open very easily. But there will be certain points on the door where, if you apply the same force, then it will be extremely difficult to open that same door. So let us watch this video. So we have a door which is hinged on the right hand side. So let's consider we have a straight line here. This will be the axis of rotation about which the door will rotate. Now let me play this video and watch, observe very carefully what is happening. If the point of application of force is on the other edge, on the left hand side, then it is very easy to open the door. But now slowly and steadily what we will do, we will try to push the force towards the right edge. So watch, the force is being gradually pushed to the right hand side. In the real world, you might have seen that it is very difficult to open the door if you apply a force which is very close to the hinges. And consider an extreme situation. If you apply the force on the hinges, which means at the extreme right hand side. If you do that, then the value of R will become 0 and the torque of that force will become 0, which means if you apply the force directly on the hinges, which is basically the axis of rotation of the door, if our forces are acting on the hinges, then no matter how hard you push or pull, the door is never going to rotate because the value of torque is equal to 0. And this is the real world impact of torques. And now let us try to solve questions based on this concept of torque. So the magnitude is RF sine theta, do remember, and we have to consider directions also. So here we go. This is the first question. So it's the same diagram, but the values of the parameters are given. F is force is 5 newtons, the distance R is 4 meters, the angle is 120 degree. So we have to find the value of the torque about two different points. First, we find the torque about the pivot point P, and then we find the torque of the same force but about the point Q. So here we go. The magnitude of torque will be given by this formula Rf sine theta under the mod sign. So let's use the formula about the pivot point P. So the value of R is 4, F is 5, and the angle is 120. So if we put all the parameters in, the value of the torque will come out as 10 Newton meters. This is just the magnitude. We still have to find the direction of this torque. So how do we do that? All we need to do is just observe how this rectangular object is going to rotate. So the force is acting on the right hand side. This force is going to rotate this rod in an anti-clockwise fashion. So we can say direction of this torque is anti-clockwise. Coming to the second case, if we have to find the torque about the point Q, this is easy. Torque of this force about the point Q is just 0. And what is the reason? The reason is the force is passing through the point about which we are finding the torque. So that is why torque of the same force about the point Q is 0. Now, let us try to analyze the torque formula in a different way. In this formula, the most important parameter is R. And why is that important? Because the value of torque will be different depending on the value of R. So consider the same diagram. We have a rectangular rod on which a force is applied on the right side. Now the angle between R and F is theta. So what we can do here, if we resolve F into two components. So let's say if we break the force into the X component and the Y component, we can say X component is F cos theta and the Y component will be F sine theta. Now the formula for torque is Rf sine theta, which is this. But what does F sine theta signify? F sine theta is the component of force which is perpendicular to R, as you can see in this diagram. So F sine theta is perpendicular to R, and that's why over here I have mentioned F sine theta is component of force perpendicular to R. And that's why the formula for torque can also be represented like this. So the torque is a product of R and the component of force which is perpendicular to R. So this is one of the ways of representing the torque formula. Let's consider the second situation. So it's the same diagram. In case 1, we had resolved the force into the two components. Over here, we are going to break the R vector into two components. So first, we have to figure out the component of R which is parallel to force. So what we'll do, let's draw a dotted line which is parallel to the line of force. Now, since the dotted line is parallel to force, so this particular angle is also theta. Now, the component of R along this dotted line will be R cos theta. And the component perpendicular to R cos theta, of course, will be R sin theta. Now, coming to the formula Rf sin theta, we can also write that formula like this F, and in the brackets, we have mentioned R sin theta. Now, what does R sin theta signify? R sin theta is the component of R perpendicular to force. So, this dotted line was parallel to the force, and now you can see the angle between R sin theta and this dotted line. This is 90 degrees. And that is why the formula for torque can also be represented like this. So torque is a product of force and the component of R which is perpendicular to force. So although we are dealing with the same formula Rf sin theta, these are two variations of representing the same formula.